This video will introduce the use and application of backloading sample holders for powder X-ray diffraction sample preparation. The backloading technique is a commonly used method of sample preparation in powder X-ray diffraction. Backloading preparation involves loading the powder samples from the side of the holder opposite to the side that is presented to the instrument, as illustrated on the right. By loading powders in this way, the sample surface presented to the instrument is exposed to minimal contact and manipulation. This technique is used in the preparation of bulk powder samples for reflection measurements. There are several advantages to backloading for the preparation of powder samples. In most cases, the backloading technique produces a higher sample surface quality and a more reproducible sample height than many other methods. In addition, texturing may be reduced relative to front-loading methods. The holders used for backloading can also be used for front-loading and for loading of thin, irregular solid samples. For more information on the loading of thin, irregular solid samples, please see the video on the irregular solid sample holder. Disadvantages to this technique are relatively few and minor. Compared to the front-loading techniques, backloading requires slightly more time for sample preparation. However, the advantages gained with backloading strongly outweigh the relatively small investment in additional preparation time. The technique also requires larger sample quantities, which are beneficial with respect to intensity and sampling statistics, but can be problematic when sample quantities are limited. Techniques exist to reduce the required sample quantity using a filler material. However, if this volume reduction is also insufficient, please see the section on the zero background holder. Although the backloading technique is the recommended use for these holders, the sample holders can also be used for front-loading. Front-loading preparation involves loading powder samples from the side of the holder which is presented to the instrument, and like backloading, is used to prepare bulk powder samples for reflection measurements. The primary advantage of this technique is its simplicity and convenience, with shorter sample preparation time compared to other methods. However, there are several disadvantages associated with this technique. The sample surface quality and height reproducibility are often inferior to backloading methods, and texturing is more readily induced due to the necessary manipulation of the instrument-facing sample surface. The sample size considerations and volume reduction techniques are all the same as in the backloading preparation. Malvern Panalytical provides several different standard 51.5 mm circular backloading holder options. The holders consist of a common base plate with removable rings containing either a 16 or 27 mm cavity. Optional pre-cut cork inserts are available for sample volume reduction. The cavity dimensions and sample volume for each holder configuration are outlined in the table shown here. After selecting the proper holder, the tools shown here will be required for backloading sample preparation. The necessary sample holder components include the common backplate and the chosen sample holder ring. The required preparation tools include the sample preparation table, the press, a knife blade or glass slide, and a dusting brush. Optional items include a cork backing if sample volume reduction is desired, a spatula for powder handling, a sheet of paper or tray to collect excess powder, and paper towels or wipes for cleanup. If the front-filled technique is to be used, the sample preparation table will not be necessary, and the press tool is also optional but recommended. A clinker sample will now be used to demonstrate how to properly prepare a sample using the 27 mm backloading sample holder. The ring is secured onto the sample preparation table using the button on the side. The sample is then placed into the central cavity of the ring while making sure to gently press the powder with the spatula to eliminate the presence of voids in the material. Keep in mind that even though a clinker sample is being used here, this same procedure can be utilized for any powder material. It is good practice to make sure that an excess amount of sample is placed into the holder. This will ensure that the sample holder is completely filled when compacted. The excess will be gently scraped into the central portion of the ring using a knife blade or glass slide, and then distributed evenly around the surface of the sample. The powder press block is then used to compact the sample. It is recommended to press the sample only once, as repeated pressing can result in the formation of distinct layers or cracks within the sample, which in turn can have a negative impact on data quality. The surface is scraped once again with the knife blade or glass slide to remove the excess powder. When doing so, take care not to damage the prepared sample. This will be more important when the sample material is adhesive in nature. After removing the excess, the back side of the holder will be cleaned with the knife blade or glass slide, as well as the provided dusting brush. It should be noted that prior to starting, a sheet of paper was placed beneath the sample preparation table to catch the excess powder. Next, take the backing plate and push it firmly onto the ring until a click is felt, indicating that it is securely attached. Now, turn the sample holder right side up and release it from the sample preparation table using the button on the side. Finally, gently remove any excess powder from the upper surface of the ring. This is especially important as it is this portion of the sample holder that is used to reference the sample height. At this point, the sample preparation is now complete. Alternatively, for small amounts of material, a cork backing can be placed in the cavity on top of the sample. Once the cork backing is in place, the sample is pressed as shown previously. Next, the backing plate can be secured in place and the sample unloaded. Once again, it is important to ensure that the top portion of the ring is clean before placing the sample into the instrument. Additionally, there is the option of pre-assembling the sample holder with the cork backing and then utilizing the front-loading method. As with the backloading method, the sample is distributed evenly within the cavity of the sample holder. The sample is then compacted from the top using the powder press block or a glass slide. It is important to remember that pressing from the top increases the likelihood of preferred orientation within the sample. This is why the backloading method is generally favored. Once the sample has been compacted, the surface is scraped with the knife blade or glass slide. After removing the excess powder, the top of the sample ring is cleaned, and the sample is then ready to be loaded into the instrument. Examples of correctly prepared 16 and 27 mm backloaded samples are shown here. The final prepared sample should have a smooth, flat, and uniform sample surface without voids, cracks, or density variations. The sample surface itself should be flush with the reference surface. Additionally, the reference surface itself should be clean and free of powder material. Problems sometimes occur in sample preparation, which may be related to improper technique or challenging sample characteristics. Examples of common issues in backloading and frontloading applications are shown here. In the top left example, the sample surface is clearly below the reference surface and exhibits a concave shape. This example is the result of an attempted backloading sample preparation in which an insufficient quantity of sample was loaded prior to compaction. Once inverted, the compacted sample collapsed, resulting in an incorrect height and shape. This same result can occur in front loading if insufficient sample is loaded into the cavity before compaction. In the top right example, the sample surface is uneven and clearly above the reference surface. This is the result of an attempted backloading preparation in which the sample ring was incorrectly installed on the sample preparation table. The same result can occur in front loading if excess sample is loaded and the sample surface is not scraped flat. The center example shows the result of an attempted front-loading preparation in which the sample was aggressively scraped after compaction. In this case, the aggressive scraping resulted in an uneven sample surface and excessive removal of material from the cavity, leaving the sample surface below the reference surface. Additionally, a large amount of powder remains on the reference surface. In the bottom left example, density variations can be seen in the sample surface. The center of the sample has a substantially higher packing density than the periphery, resulting from an attempted backloading preparation in which the sample was concentrated at the center of the cavity at the time of pressing rather than being distributed evenly. The same result can occur when front loading for similar reasons. Finally, in the bottom right example, a void is clearly visible in the center of the sample, the result of an attempted backloading preparation in which the sample adhered to the sample preparation table. When the holder was removed from the sample preparation table, a small amount of material adhered to the table and was pulled off of the sample surface. Voids such as this can also occur in front-loading applications during compaction for similar reasons. In backloading preparation, voids can occur when the sample quantity is insufficient or when the sample is not spread evenly throughout the cavity prior to compaction. In these cases, voids most commonly occur around the periphery of the holder cavity. For more in-depth information or to contact us directly, please visit our website at www.malvernpanalytical.com.